Kubectl plugins like a pro.
Yes,
Okay.
yeah. Awesome.
One thing before you go, Ahmet was today at the Contributor Summit, and he asked for help for the Kubectl
Plugin manager.
Yeah,
Yes.
so you can do the same thing.
Yes,
now,
we'll
right?
do the same. Okay, hello everyone. My name is Ahmet. So today we're going to talk about Kubectl plugins. I'm probably going to say Kubectl a few times. I might say Kubectl a few times. You know, just warning you. Don't get too confused. Kubectl is an option as well. So I'm an engineer at LinkedIn. I lead the cluster management group. Prior to that, I worked at Twitter, and before that, Google Cloud and Azure. So I've been in Kubernetes and container space practically all my career. This is my after 5 years, this is my first time of visiting KubeCon, so I'm very excited. You might know me from the open source, you know, through various Kubernetes CLI-based tools that are rather popular among developer community. So today we're going to talk about the plugin machinery in Kubectl. And then we're going to talk about Krew, the plugin manager in Kubectl as well. And then we're going to talk about writing idiomatic CLI tools. And there we're going to have a lot of demos. I'm going to walk through a lot of code, so stay focused. Hopefully you got your coffee going. We're going to talk about flags. We're going to talk about resource querying patterns and stuff like that. And then at the end, I'll try to do a, you know, what are my favorite Kubectl plugins? Obviously, it's the ones that I wrote. So, you know, we'll talk about a few more. Okay. So is this talk just about Kubectl plugins? The answer is no. A lot of CLIs out there query the Kubernetes API, right? Istio CTL does it, probably Istio Kubectl, whatever you call it. Knative has a CLI that does the same thing. I mean, an hour ago, there was a demo upstairs. Someone demoed the, what was it, Cloud Native Postgres, and they were showing a Kubectl plugin as well. So these are like rather popular tools. So this talk is pretty much relevant to developing any CLI tool that is going to query the Kubernetes API at the end. So let's talk a little bit about the plugin machinery in the Kubectl. But before we go there, I want to also explain why would you develop a plugin, right? Obviously, Kubectl doesn't give you everything you want. So you want to create extensions to Kubectl that feel the same way, right? Git has many of these extensions. You can install fancy Git plugins into your shell, and you type Git something, and it feels like it's part of the Git, as if it just comes in the package, right? So one fun thing that you can do is, if you work at a company that controls the developer environments, you can pre-install these tools to people's machines, and people will think, wow, this tool is just part of Git, right? I didn't install it myself. So we do the same thing at LinkedIn, actually. We have our own internal CLI that we install as a plugin into Kubectl. It's called Kubectl in, and a lot of internal developers don't install it themselves. It's just there, and they think it's part of the experience. So part of the goals of the project is to feel natural. So let's talk about the plugin machinery and how it works. Surprisingly, it's extremely simple. The plugins machinery was introduced in 2017, Kubernetes 1.8. That's really, really old at this point. And one thing that you can do is obviously add commands to Kubectl, but you can't shadow the existing built-in subcommands. Like, you can't create a Kubectl edit that is your own. You can't create a Kubectl create of your own. So main reason for that is obviously security. People don't want to replace the entire Kubectl machinery with something that happens to be existing in your path. So the way again, plugins work is you create a binary or executable, could be literally a bash script, no one cares. As long as it's executable, you just put it in your path, somewhere in your path, doesn't really matter where. As long as it's called kubectl-foo, you can invoke it as kubectl space foo. Simple as that. Now again, if it has double dashes in it, or like, you know, the dashes in the middle, you can call it multiple ways. It can be kubectl foo space bar, or could be like foo dash bar. So this is, again, rather, you know, it's open for interpretation, but if you want to unambiguously define it through a dash, you have to use an underscore in between. So that's kind of how the plugin machinery works, and it's super simple. There's practically nothing else you need to know about the plugin machinery to develop one or use one. Now, Kubernetes 131, which just released, introduced a new type of plugin system. It is called create plugins. So for a really long time, we've seen a lot of developers, a lot of vendors creating their own plugins, right? Like, for example, you have a Postgres operator. You distribute a Postgres CLI just so that people can have a create command. So now you can instead flip that Postgres create, and you can do create Postgres. So as a result, you can now create plugins that are prefixed with the create dash. Again, if you recall from the previous slide, you could not overshadow an existing subcommand like create, but now you can. Now, the caveat there is it's not going to show up in the Kubectl create list, but you know, it might. I don't think anyone thought about contributing it, so it actually can be done. Okay, so this brings us to where do I find plugins? How do I, you know, package them and distribute them? So Krew Plugin Manager is a Kubernetes SIG CLI subproject. You can find the project at krew.sigs.case.io. So this project started as an intern project, actually. I had an intern at Google in 2018, and we were like, let's just develop a plugin manager. Why not, right? No one's going to do it if we don't do it. And then the project got accepted into SIG CLI in 2019, a year later, and we maintain a hand-curated list of plugins. Like, we literally tell people, yeah, your plugin sucks, you can't submit that here. Or we tell them, yeah, this plugin is great, but did you think about like adding this feature? Or did you think about like changing your help message to look like this so that people can find your plugin better? So we actually spend time with plugin developers to curate that. Rather, it's not a pristine list per se. Like, we still accept a lot of plugins, a lot of stuff gets through over time, but it's a hand-curated list. Now, you might wonder, like, is that really a good idea? Because like Helm used to have these curated charts, and they actually abandoned them because it doesn't scale. And this is where I do my plug. We hand maintain these lists, and there's actually one maintainer that looks at these plugin submissions. So anytime a new plugin comes in, sometimes they wait in the queue for a week and a month until we realize that, turns out I forgot to check my email. Turns out it just got lost among my emails. So I don't realize that the plugin submissions came through. And it's concerning given that there are 275 plugins already distributed through Krew. So if you submitted a plugin and FI didn't answer timely, you now know why. So if you're interested, please contact. We're trying to establish some governance and guidelines around how do we accept plugins, how do we review them, and so on and so forth. Okay, so when plugin machinery first came out, we thought that, okay, we're probably gonna ever have 50 plugins, so let's not write the most perfect code that can be written. So there's a lot of crap that is in Krew today, and the community has proven us wrong over the years, and the plugin submissions to Krew only has been steadily increasing. Like, if you look at the trend line, it's sometimes above the curve, sometimes below the curve, but it's actually pretty much going pretty healthy, which is fairly interesting given like the stability and maturity stage that Kubernetes has reached, right? So as of, I think at this time, there's 277 plugins on Krew. But yeah, there's a pretty big increase. So every 6 months, I think we go something like the 50%, no, something like that. Anyway, I forgot to do the calculation. Okay, so this brings us to the beefy part. How do I develop a CLI tool that feels like Kubectl, right? You can certainly re-implement Kubectl yourself, but we're not going to do that. We're going to build something using the reusable blocks from the open source, and we're going to put them together, and hopefully this is going to be an easy demo. So the demo is going to be multiple pieces, but let's first try to understand how does it look like to feel like a Kubectl plugin. Well, the first thing is you have your CLI options, right? When you do kubectl-help, you see some certain flags that are just everywhere. Like, even if you go to Helm CLI, if you go to istio-ctl, whatever, like all these flags are there. The -- context, -- namespace, right? All these standard flags are part of the experience. Like, it doesn't make you second guess what you're using because it's part of the experience that comes with kubectl. And then the second thing is the configuration and context awareness. So for example, if I have a kube-config file, which all of you do in your home.kube.kube/config directory, right? You can have multiple of that. Did you know? Like, you could actually list multiple kube-config files in the kube-config environment variable. But if the tool doesn't understand that you have a kube-config environment variable, well, all that goes out of the window, right? I can't just use istio-ctl if it doesn't respect the same environment variable. So the consistency is part of the story here. And similarly, we expect that the commands in other plugins or other tools will be organized using the verb and resource, just like kubectl create pod, kubectl scale deployment, right? So this is another area where we expect plugins to kind of look and feel the same way. And similarly, the common way of specifying resources. Like, let's say I want to query all the pods. What do I do? Kubectl get pods, -- all namespaces, right? So this feels natural. Similarly, I can query a service named foo. I can say service/foo. I can also say service space foo, right? So there are all these different ways of querying resources. You can literally specify -f deployment YAML. You can pass that to the delete command, and it finds the resource in the file, and it deletes that resource in the cluster, right? So when you develop a tool like that, it will be ideal to do so. So we're going to start with the generic CLI flags because this is the easiest thing you can do, and this is the first code that I'm going to show here. So when you type kubectl options in your machine, you're going to see that there are a lot of like common flags in every single kubectl subcommand, right? The dash dash context is part of that, dash dash namespace is part of that. So as a result, you get these like common arguments that configure how does the CLI find my cluster and talk to it, right? So as you can see in the code, this is very easy. You just import the CLI runtime, which is a Kubernetes SIG subproject, and then they offer a generic CLI options package, and then you just add it to your command line flags, and you're good to go. Actually, I'm going to do that demo really quickly. So if I look at my code here, you're going to see that. Again, I have that exact code that I showed you. And if I, let's install this binary, and now Go compiler is really slow for whatever reason. I'm going to have it, because this project was called kubectl-demo, I'm going to have a binary called kubectl-demo. And guess what? It's not going to do anything. It's just going to, obviously, it's not doing anything, right? It's just parsing the flags and exiting. So if I do -help, this is where you see that this looks very familiar. This is like, all the context and, namespace, timeout, kubeconfig file that I had in the kubectl file, kubectl. Okay, so that's good. Now you're off to a good start already. Now, here comes the next step. Usually an empty CLI that does nothing is not a good use to anyone, so you need a client. You're trying to talk to the API server, you need to find the API server, and to do that, the first thing that you do is you get a REST config from the kubectl, and that's like, how do I, what is my API server address? Where is the certificate? What is the token that I'm supposed to use, right? And then you initialize a Kubernetes client set. So this is a typed client set, meaning we know the types like pods, namespaces, etc. ahead of time. And now, here in this example, I'm building a discovery client, and I'm going to query the server version of Kubernetes, right? So let's show you that demo as well. Let's check out the other branch. Let's do git checkout step 2. Okay, so now we're in the step 2, so it's the exact same code that I showed you. I'm going to parse the Kubernetes API version from the server, and I'm going to just type it on the screen. So again, the flags are still there. Let's go ahead and compile this. Go install. Okay. Again, Go compiler is going to take its sweet time. Kubectl demo. So because I'm talking to my local kind cluster, I'm just going to say it is 131 as expected, right? So all we did here was to initialize a client set. Now, one thing that you'll realize here is that I can do client set dot core v1 dot namespaces list, whatever Copilot tells you to write nowadays, right? It's very easy to get started using the typed clients, because they're part of the client's Go, right? They're part of the built-in API, so you're having a pretty easy time here already. Okay, so let's go to the next step. Now, I want to select some resources. I was telling you, what if you could implement your own kubectl get command? I want to implement the fancy get, right? I've found ways to query pods by annotations or some other fancy thing. It doesn't really matter. All we're trying to find out is, how do I query resources? So this is where the CLI runtime resource builder comes into play. So you just initialize it using the builder pattern that you're familiar with already. Then you pass your command line arguments to the resource builder, right? Like get pods, get services, or kubectl get service/foo. So all these are command line arguments. Or you can say that I'm not interested in all kinds of resources. I know the resource type. It's pods, and here are the names. Right? You can do that too. So that basically means your users can only query the pods, and the positional arguments to your CLI will be the pod names. So obviously, I'm not going to show that. I'm going to show the one in the middle. So let's go to that demo already. Git checkout. Step 3. Okay, let's go to our main.go. Okay, so here's, this is the beefy part. So we initialize the builder, and then we told that, using this scheme that is already part of the kubectl, meaning the built-in resources, because I'm going to query pods. I'm not going to query CRDs with this yet. I'm going to show you how to do that too. I'm parsing my positional arguments to the resource builder, saying that this is either resource type, like pods, or it's the name of the resource. And I'm going to get a visitor function here. And the visitor function, basically, every time it finds a resource, it's going to execute this little block here. And this block basically is going to print the namespace, and it's going to print the object name and the object type. So because I'm going to query pods, you're going to see pods. Let's just go ahead and execute that. So go install. Again, this is Go compiler at work. So kubectl demo. Now, when I run this, I'm going to get an error because I didn't specify any positional arguments. But you know, the error looks very familiar. This is what happens in kubectl get as well, right? If I do kubectl get, what is going on here? Well, it says something similar. I don't know why the library says something different, but it's basically the same idea. So it basically says that in the demo plugin that I had, you should either specify a file name or some resource names and stuff like that. So let's go ahead and say kubectl, because I'm in my kind cluster, let's do kubectl demo pods. Okay, so this is exactly what I was expecting. Look, I didn't write any code. I didn't say go query pods. You know, you can say pods, you know, v1.pods. There are multiple ways to query these objects. There are like multiple ways to refer to them, and I already solved that problem. Like I can already use whatever kubectl uses, right? So one thing that you'll notice here is that these are already using all the namespaces. And like the command, I didn't tell command which namespace to use. And funny enough, there's probably actually a namespace command in the help message, right? There you go. But we didn't use that. It's because I didn't configure the code to do so. Another thing that you'll notice is that the type of the object that I got is a v1 pod. So meaning I actually got a Go object of pod type. What if I had CRDs? Like what if I work with any type of resource, like Istio resources, Knative resources, right? I couldn't do that because the built-in types do not allow that. So this brings us to our next topic. You either basically choose to work with a scheme or you work with custom resources, any type of resource that you have, and use the unstructured client. So what the hell is unstructured client, right? So unstructured client is basically just like it's not treating the API objects as Go types. It's leaving them as just maps. It's like, you know, unstructured JSON objects, right? But if you own your CLI and your CLI only works with custom CRDs, then you actually can still use the scheme method that I showed up there and register your CRD scheme and not do the unstructured objects. Because once you go to unstructured objects path, you're basically writing Python code, right? You're saying, okay, I'm going to go to the spec field, and spec field happens to be a map, and you're going to go to this array. So you're writing a lot of code to deal with the unstructured objects, which I actually did in one of my plugins, but it's fine. So this brings us to the next demo, which is basically using the unstructured. So how do I do that? Let's do git checkout. Step 4. Okay. So all I did was there was like something here that was saying with scheme, and I replaced that with unstructured. That's it. I just said I want unstructured. I don't care. So when I run this command, let's do go compile and kubectl demo. Okay, I forgot to add the pods. Now, as you can see, I'm getting a whole bunch of unstructured objects. So if I were to look inside them, I'm going to see that they're pods, but I have to reach to certain fields to read that, right? So this is great. You know, it basically is showing you that you can build whatever you want with this, and like you don't have to worry about whether it's a CRD or a built-in resource. You're already off to a good start. So this brings us to the next topic, which we alluded earlier, which is how do you figure out which namespace to use? So this is an area that admittedly the CLI runtime package falls short because there are multiple ways to pass namespace to a kubectl kubectl command. One is you can obviously say, I want -- namespace this thing. So obviously that should take precedence. Alternatively, you might say, I want all namespaces. Funny enough, in kubectl, you can specify both at the same time. And then lastly, there's this tool called kubems, or you can use kubectl config command too. You can switch into another namespace. You can say, for this cluster, this is my default namespace, so please assume this is the default namespace you should interact when you're creating resources or creating resources, right? So unfortunately, the existing code doesn't handle that, but thankfully, it's not too hard to do so. So I'll show you how to do that. This brings us to the next step, which is step 5. Okay, so the first thing that I do is register an all namespaces flag because it doesn't come out of the box. And obviously, I pass the flag. The next thing is I'm loading the kubeconfig file for this cluster. Just for this cluster, I want to understand what's in that config and whether there's a default namespace set, right? And after that, I'm like, if there's a -n flag, -- namespace flag, use that. That's not there. Use the one in the kubeconfig file, right? So that brings us to how do we configure that. Again, super easy. You basically say that this is my namespace, allow the default to happen, and whether there are -- all namespaces specified true, just use that, right? So let's try that real quick. I'm going to go to my terminal, go install kubectl demo. Yeah. Kubectl demo pods. There you go.
because I was in the default namespace, you know, that thing works. If I do dash kit system,
Another thing, printers. This is a pretty, complicated topic, admittedly. So normally, you have to write your own printers, but recently there were print flags added to Kubectl get that you could directly use out of the box. So this is not in the CLI runtime, but you can very easily add a bunch of flags about your printing functionality. For example, here I'll go to that real quick as well. So here you can see that from kubectl get, we can add a whole bunch of print flags into our command set. And from there, as you can see here, in our visit function, we're just going to print the object. So if I show that real quickly as well, let's do go install. And then we'll do kubectl. Wow, this time compiler is really slow. Okay, kubectl demo pods. Actually, I'm going to show the help message first. As you can see now, we have some -- output, for example, right? So I can support JSON, YAML, whatever it is. And you get actually a lot more flags as part of that. So if I do kubectl demo pods, again, I'm getting these, nice table. If I want YAML, I'll get YAML. Again, works, just like how you expect it to be. You don't have to write pretty much anything. It's still we're still under 50 lines of code. Keep that in mind. Okay, the next thing is server-side printing. This is another funny thing. So when I was just showing you the demo over there, did you notice that the kubectl get demo pods command actually didn't show you anything about pod readiness or how are the pods doing? Well, that's because as of Kubernetes some version, I think 1.15, Kubernetes does the calculation of what columns show what value in the server side. That little running column over there, there's 100 lines of code behind that little running column. And so don't try to replicate it. What you can do is you can still get it to work in your CLIs, and that brings us to our next step, which is kubectl. Actually, I'm running low on time apparently. Okay, 3 minutes. Yeah. Okay, so let's go to step 7, which is our last bit of code that I'm going to show you. So one thing that you can do here is you can tell the request builder that, sorry, I messed up the code. Actually, let's reopen the file. Okay, so you can add this little header, which basically says that I want my requests to come as table if the output is human readable, which is output wide or table, whatever it is. And this basically says that send me a v1 table object, right? And the table object is, again, not a real API object. It's just something in the API machinery. If you go install, and if you do kubectl demo pods, boom, you're suddenly getting all the funny flags that you got from the server side. Okay, so that was pretty fun. We didn't show how to select from the file or selectors, stuff like that. More tips, adjust your client-side rate limiting. Your plugin, if it's querying a lot of stuff, you're going to run into rate limiting. And if you make a large list of calls, maybe paginate them, so specify something like 1,000 so that you don't overload the API server with a lot of memory usage. So a lot of what I explained actually was in a blog post. I discovered that while I was writing the talk, unfortunately, and there are good examples. So take a picture of this slide. It's a good idea. Yep. So another set of recommended resources, again, basically what I showed on. I have some example plugins like Podzone, Con, basically do the same thing. Now, I'm going to blaze through some useful plugins, okay, in 1 minute. Who can? Okay, so this is something in Krew, shows you who can do what. Who can get secrets? Pretty fun. You can't do that with kubectl. Get all. Kubectl get space all doesn't work because it only works with built-in API resources. This enumerates every single API resource type, so it shows all the CREs and everything. Kubectl tree, this is something I wrote, shows you object hierarchies. Who owns what resource? That's kind of fun. Kubectl for each, again, unfortunately something I wrote, but it lets you execute a command against multiple clusters. We use this all the time because it's super helpful querying what's going on in my fleet. Kubectl images shows you which pod, which container is running what image. Kubectl needs, if you have an existing resource. If you want to export that to a nice YAML file with no boilerplate crap like generation and creation timestamp, whatever status, cleans up all that and puts that out there. Kubectl con, this is something I wrote as well. It shows you conditions on objects. If you want to crosstalk, you'll see conditions are super useful. Blame, fields. These are also plugins that show you who edited which field. So you can see a pod was created by a kubectl manager, and its status, which field was updated by who and when. This is pretty useful as well. Thanks for coming to my talk.
We have 5 minutes for questions, so, yeah.
I'm going to ask the controversial question. Suppose I'm developing a Kubectl plugin in a different language that doesn't have like all of this nice stuff. I can imagine a world where Kubectl itself is able to parse all of these flags, and then there's like some sort of communication to the subprocess where it's able to handle this stuff. Is that something that is
We
ever
haven't heard
feasible?
the demand for it because like 99% of the plugins are written in either Bash or Go. So that never really like came up as a feature request per se. But again, we're also lenient about how plugins look and feel. There are plenty of plugins that don't do anything I showed here, and they're fine, you know, as long as people can figure out how to use them. Scott says we should make that plugin. Actually, that's an interesting idea, yeah.
I've actually written a plugin like that. That's an
Yeah.
internal CLI, or not a plugin, an internal CLI in Python that does a lot with like the Python typed clients.
Yeah.
One of the big points I've run into is with the port forward command, because I want to programmatically establish a port forward to do some operation. I hadn't realized until I got into the weeds that that was really a client side thing that's being done in Kubectl and not server side. So I would support that kind of effort.
Yeah, I'm invalid, but I mean, feel free to propose that. Scott says something or any other question.
Do you have any general advice for when something should be a Kubectl plugin versus when it should just be like Istio control or whatever?
If it's managing generic Kubernetes resources or like you have your own CRD, I think it makes sense to be a Kubectl plugin. But a lot of, you know, Minikube is not a Kubectl plugin. Neither is Helm. Neither is Kind, because they don't manage Kubernetes resources per se. Like they do their own thing, and I think there is no like clear, you know, I can draw a line and this is plugin, this is not. We have like log tailing commands that distribute standalone, like Stern or Kale, whatever. But they also distribute as a plugin under a different name or something like that. So there's, you know, there's no free format.
We have a few more minutes for questions. Anyone? No? Okay.
Scott,
Yeah.
Scott really wants this.
Why did you reject my Krew submission?
I reject your. I don't think I did. I don't think I did. Sweet.
All right. Thank you, Ahmet.
Thank you.
With that, that was the last one for this stream. We have one more in the theater, and don't forget to